Hi everyone, today you will learn about position time graph.
Our objective is for you to describe how to draw position time graph, what are its components, explain how position time graph shows the velocity of a moving object, and calculate the velocity of moving object from position time graph. Okay, but before that, let's review first on the equation for average velocity. So we've talked about this 2 weeks ago, and of course, average velocity formula is always displacement divided by time. And always remember, displacement can be changed. You have final displacement minus initial displacement. Your time also, if there's two or more, it's going to be final minus initial time. And then your formula is displacement or triangle D divided by change in time or triangle T. We're going to look into that later and use that in solving for velocity in graphs. Okay, so the graph that we will be focusing for today is the position time graph. So the motion of an object or any moving object can be represented by a position time graph. In a position time graph, it is very important for you to understand that there are 2 points. You have the vertical axis and you also have the horizontal axis. Axis is horizontal. Is it X or Y axis? This one. Horizontal axis is your X axis, while your vertical axis is your Y axis. Always remember that when we're doing graph, time is always on the horizontal or x-axis. So x-axis is your time, and the usual unit is seconds or s. And your y-axis is your position or your displacement, and the unit is always in meters. Okay, now, most of the time when we do graph, there should be a table where the result is located. And then from that data table, we can be able to plot the informations on our graph. So aside from the points, x-axis and y-axis, we also need to have the data. Okay, so on the table here on this side, you will be able to see here time and position data. So for the time, it's 0 to 6 seconds. So this will always be your 0, of course. Then 1, 2, 3, 4, 5, and 6 seconds. And then for your distance or for your position, that's 0 to 30, increments of 5. So you have 5, 10, 15, 20, 25, and 30. Okay? And then basing on that pair, your X and Y, you have to plot them on your graph using a straight line. But it depends. Sometimes it's curved, sometimes it's straight, depending on the data. So it starts from 0 and then paired up with 0. Your 1 second is paired up with 5 meter. And then your 2 seconds, 10. And then your 3 seconds is 15. 4 seconds is 20. 5 is 25. And 6 is 30. Okay? So that's how you draw the graph. They are paired up, 5 and 1, 2 and 10, and then so on and so forth. And then you draw a straight line to represent the graph because lines there will have meaning. Okay, so again, in drawing graph, those are the most important thing that you need. You need to have your y and x axis, you need to have the data, you need to plot the points to where it should be, and then draw a straight line after that. Now, aside from that, it is also very important for us to read and analyze and interpret what the graph is showing us. For example, here, a position time graph shows how far an object has traveled from its starting position at any given time since it started moving. So for this graph, for number 1 graph, question, in the figure above, what distance has the object traveled from the starting point by the time 5 seconds have elapsed? So you should be able to know how to read the information that you have on your graph. It is 50 meters. 50 meters in 5 seconds, 40 meters in 4 seconds, 30 meters in 3 seconds, 20 in 2 seconds, and 10 1 second. Okay? So another thing which is very important for you to understand in a graph is its slope. For position time graph, slope is equal to velocity. So meaning this one, the y-axis is your position, the x-axis is your time, and then the slope is your velocity. Okay? So slope or steepness of the graph line. If the graph line is horizontal, like the line after time, this one, horizontal, 5 seconds in graph 2 in the figure below, then the slope is 0, which means the velocity is 0. The position of the object here is not changing. But the steeper the line is, the greater the slope of the line is, and the faster the motion of the object is changing. So for this one, this is an example of a 0 slope. And since slope is velocity, therefore this is a 0 velocity, or the object is at rest. Okay, how about this one? If this is how the slope looks like from 0 to 5 seconds, if this is how the slope looks like, what does it mean? Does it mean velocity here is changing or velocity here is constant? This one is an example of a constant velocity. When we say constant, the velocity is the same all throughout the journey or all throughout the travel. So if it started at 10 meters per second, it will continue at 10 meters per second. So the right answer is constant. Next question. Is it positive or negative velocity? So this one is a constant positive velocity. Okay, constant positive velocity. So aside from this slope, there are any other slopes, and it can be interpreted in some other ways. So for this one, we know that this is constant, this is rest, this is positive. So let's take a look at the other interpretations. So interpreting velocity graphically, for any position time graph, we can determine the average velocity by drawing a straight line between any 2 points on the graph. So we have 2 points there. Remember, you have your distance or position as your y-axis, and then you have your displacement, or your time for the x-axis. So in the middle of those, that would be your velocity, or the slope is your velocity. So if velocity is constant, the graph of position versus time is straight line. Slope indicates that the velocity is number 1. So for object 1 here, the velocity is positive, constant. For object 2, 0, not moving. For object 3, negative, or negative velocity. So here are some examples here that I want you to familiarize. So the steeper the slope, the higher the velocity or speed will be. And the slope, again, the slope, the green color line here represents your velocity. So your slope is your velocity. So for the first diagram, slope is on horizontal line. That means to say that the slope is 0, which means velocity is 0 because slope represents velocity. And if you will explain that, you can say that in this graph, it shows that the object is at rest or the object is not moving. Okay, for the second diagram, the slope here is positive, therefore the velocity is constant and also positive. So I'm going to show you later for our calculations if really this diagram shows constant velocity, because we will be solving graph later. So we would know if this shows positive or constant velocity really. For the third diagram, slope here is negative. So if it's like opposite to your positive, it's going back. Your slope there is negative, which means your velocity is negative, but constant because the line is straight. However, for the fourth diagram, it shows a curved line. If the slope is curved, which that means to say velocity is not constant, which means object is accelerating or object is changing its velocity from time to time. It could also be like this. So it depends. Sometimes it's like that, and then others like this. Still, that is changing velocity. So your velocity there will not be the same all throughout the journey. So focus on that, familiarize. And then the next one is So how do we calculate for position time in order for us to get the velocity? Okay, and then we're going to check if indeed this one shows constant velocity, if our velocity will remain the same when we solve for it. Okay, so solving for velocity. So as what we've learned 2 weeks ago, in calculating for average velocity, we can use the formula displacement divided by time. So average velocity equals the change in position, which is your displacement, represented by triangle D. Triangle means change, divided by the corresponding change in time, represented by triangle T. So we have velocity is equal to triangle D divided by triangle T. However, in the graph, we know that velocity is the slope. So you can use slope is equal to triangle Y divided by triangle X. Okay, so when you have a triangle, that means to say there's changes. So it could be YF or Y2, final Y minus initial Y, divided by X2 minus X1. So again, your slope here represents your velocity, your Y represents your displacement, and your X represents your time. Okay, so x-axis is time, y-axis is displacement or position, slope, the line in the middle is your velocity. Okay, let's have examples here. Okay, for example, in the figure below, the average velocity between 0 seconds and 5 seconds is, so this is your 0 seconds. That's why it is important for you to know how to get the informations in the graph. So this is your 0 seconds and this is your 5 seconds. So you need to get the informations here, such as what? You need to get the X or the time. So your time is 5 seconds and 0 seconds. Your displacement or position, in 5 seconds, you have 25 meters. So in 5 seconds, you are paired with 25 meters. And then, of course, in 0 seconds, you are paired with 0 meters. So using the formula, distance divided by time. So you just plug in the numbers. 25 is your final displacement minus 0, which is your initial displacement, divided by 5 as your time minus 0. 25 divided by 5 equals 5 meters per second. Or this one is your triangle Y divided by triangle X. Your triangle Y here is Y2 minus Y1. Divided by X2 minus X1. Your Y2 is 25 minus Y1, which is 0. And your X2 is 5 minus X1, which is 0. And then you just plug in the numbers and then subtract and divide. So we'll have more examples after this. Okay, for you to know, to understand clearly how to solve for the informations on the graph. Okay, now in this graph, from 0 to 5 seconds, is it constant or not? Okay, this one is constant. Therefore, whichever portion you will solve, you will still get the same answer, which is 5 meters per second. So let's prove if it's really constant. So earlier you solved 25 and 0. This time we're going to solve, let's say, 4 seconds and 2 seconds. So 4 seconds is paired up with how many meters? 20 meters. And then your 2 seconds, the displacement is 10 meters. Okay, so using the formula, y2 minus y1 divided by x2 minus x1. So it's going to be 20 minus 10 divided by your seconds, 4 minus 2. 20 minus 10 equals 10. 4 minus 2 equals 2. 10 divided by 2 equals 5. Therefore, your velocity is still 5 meters per second. So that proves that the line that looks like this represents constant velocity. How about this one from 5 seconds to 10 seconds? Based on how it looks like, how the line looks like, what is your velocity here? 0. And if you do the math, it will still be 0 because your final here is 25 meters minus 25 meters equals 0 divided by 10 minus 5. So 0 divided by 5 is equal to 0. So this is 0 or at rest. Okay, I hope it is clear now. We'll have another example. Okay, so on this example, you have seen also the response here. This is constant, therefore their velocity remains the same. What is the velocity of the following object here in the position time graph? So for this one, they choose to solve 4 seconds and 3 seconds. So 4 seconds is paired up with 40 meters and 3 seconds is paired up with 30 meters. So your final is 40 meters minus initial 30 meters equals 10 divided by 4 minus 3, 1. So 10 divided by 1 equals 10. So we follow, class, the graph equation, which is rise over run. Your rise is your y-axis, and then your run is your x-axis. So you just subtract and divide for you to get the answer. Okay, so this is constant still. Now for the next one, you're going to do it. So you were given here 5 seconds and 25 meters. That's your final time and final displacement. Then your initial is your 0 seconds and 5 meters. So I want you to solve for it. Okay, very good. Formula y2 minus y1 divided by x2 minus x1. So you have 25 minus 5 divided by 5 minus 0, still 4 meters per second. 4 meters per second. Unit is always meter per second because we're dealing with velocity. Okay, so I hope you don't have any more problems with this.
Thank you so much for watching. I hope you learned something today. See you next time. Bye.